Hey, good morning, everyone. Today we're covering a two-in-one webinar series. We're doing the LR100, which is the family of level radar, compact level radar, and we're then moving on to a new SITRANS condition monitoring system. So just to take you through the LR100. Yes, this is the concept. If anyone is familiar with the ultrasonic range, it works the same. So if you can see that little pulse there, that's the transmitter head. It fires down the signals. Here in our case, unlike ultrasonic, these are microwave, in microwave form. This is radar. It hits the surface like so, and it comes back up. Now, the level you've got in the tank is dependent on the time it takes for that signal here to hit the surface and come back. The quicker it takes for the signal to come back means obviously that there's a shorter distance between the emission and reflection, so it means there's a higher level. Or the inverse is applicable if you're talking about you're measuring distance or space within your tank or vessel. Now with radar, it's different to ultrasonic in the sense that the ultrasonic is just sound waves. So the name suggests it comes off, it will hit any bulk surface. There's a solid or liquid, there's something there, it will hit it and reflect it. With radar, it's dependent on the dielectric constant, also known as sort of dk, you'll see in the data sheets. The lower the dk, the lower the reflectivity. So in the legacy versions of the radar, they had trouble where it wouldn't read through, it shoot through down to the bottom of the tank and reflect up, ignoring the actual surface of liquid in there. The newer range that we've got does make a key difference. There are things like oils, which are less than 5 dk, that weren't always picked up by the older radar. There's also fibrous materials. You could have sort of wool, even cotton candy, or certain funny solids that would absorb the reflections. But we're going to go tackle that later as well. What is the deal with newer radar, higher frequency? We've got 80 gigahertz now that you'll see for the LR100 range. In the past, they were 5 to 26 gigahertz, and some of the LRs are running at that frequency. They had a lower frequency but higher wavelength. Now they have obviously higher frequency and smaller wavelength. There's an analogy that I've been taught, and I think it's really handy here. Think of the 25 gigahertz as a big ball of football that you drop on a staircase, and think of the 80 gigahertz, which we're discussing today, the LR100, as a ping pong ball being dropped onto that staircase. You drop that football on the staircase, is that going to return to your hands, which was the sender of the signal? Probably not. It will bounce off another direction. But that ping pong ball, which is the 80 gigahertz, that will probably pop back up to sender. So they're smaller wavelength, they hit surfaces, uneven solids, low reflective media. This has a chance of, because it's small, it fits within that, at the micro level, and it will hit back to your sending. And obviously it's a central point. The radar is fixed. It can only receive at these points. So smaller wavelength means it will come back to sender. And also because of just general advances in technology, these 80 gigahertz radars are now smaller. You can do without this antenna or horn system, a lot more compact to get into those tricky spaces. And we all know everyone's trying to fit level devices into small nooks and crannies. So this is where Siemens were taking it. Again, so, we're not talking about time-consuming and costly modifications to the vessels, and radar will always come out on top when it comes to certain pressure of that headspace, temperature swings, and we'll go through some examples later as well. So why the narrow beam? As you saw here, we've got it becomes narrower as the operating frequency increases. Narrow beam is obviously, if you thought the large wide beam of the 5 or 26, then beam would probably hit here, the sides, and you in a tall silo, could be 15, 20, 30 meters, say you're trying to read the bottom, and with the narrow beam you will be reading right through down to the bottom. Even over larger distances, it's been reported to still work and read only the bottom and not hit the sides. If it hits the sides, it could reflect and go back up. So you're getting unreliable readings. You're getting that as a reflected surface rather than the bottom. So when I said LR and you think, what do they look like? What are they? This is the range, at a glance. What is a common factor between all of them is that they work at sort of recent, sort of ambient to increase more than normal pressure ranges, and the temperature ranges are also, they all work at the same high sort of temperature range, so they're all applicable. They're all made for, ready to meet the needs of, your harsh, challenging sort of environments. It's just a snippet of their abilities. If you wanted a hazardous one for a hazardous area, this is, diesel, fuel, oil level, then you will go for the LR150 or the LR110. And it depends like how you're mounting it. If you're screwing it into a vessel, you might want, if you just see my pulsing cursor, you might want something like that to screw into the actual vessel itself, threaded end. Or if you wanted to mount it over an open whale, then you could use something like the LR100 or the LR110, like so, because they can be mounted, they just hung like a chandelier almost. And there's obviously options for attachments. We've got, submergence shield for flooding protection, but it's more to keep gunk and messy stuff adhering to the face of the radar. The radars can read through without dead space concerns, so that's why radars are sort of the hot topic these days. So it's all about horses for courses. Just what do you or your end user need, and choosing the right one of these 5 options to meet that need. Okay, so when we talk about what's so good about it and how does it improve on the past, well, it depends. There's a lot of there's contact switches that we've used in the past that we've quoted for. They could be tuning fork or paddle switches, and obviously with, say, a paddle switch, it could get caught on material. It will fail because it's a mechanical motor. It keeps hitting resistance. It will get knackered. With float switches, you've got whole, legacy of Halt switches that go back to the 1950s, 60s, and 70s. They are still popular nowadays, but they can be caught on, something that's gelatinous, something that's really viscous. It gets stuck. It requires maintenance. So non-contact, meaning minimal maintenance required. Even with vibrating forks and capacitance technologies, you will experience sort of density material. If it's granular, if it's small, it could change because of humidity or moisture, and it compacts around the edges of that vibrating fork, the prong, usually a single prong, and that can fool it. It could tell it to switch on when in fact it's not in the bulk solid itself. Again, with ultrasonics, while ultrasonics are sort of championed because they've always had dedicated controllers used for them and they're pretty reliable, there are certain cases where sort of fuel oils, where there are acids generating blankets of vapor, where it would change the velocity of sound in that headspace. So this is where radar's unaffected. Radar just travels through. It can travel through a vacuum, through space even. So it's not dependent on the temperature or pressure conditions of that empty space in your vessel. When I mentioned dead space earlier, there is a certain level. If the level of the liquid is too close to the face of the ultrasonic transducer, it will not read reliably, or it will fail high, or it will give you an error message because it cannot process. The time it takes from the emission of that ultrasonic to the surface and back is too short for it to give you, a meaningful reading. It's such a short time interval, but it's not the issue with radar. So as I mentioned, the volatile liquids and certain places where you could have a desert outpost where it's -10 at night and in the day it's +30, +40, and say something like diesel or diesel will probably, even if it's in that sealed system, it will boil off. So, as it reaches midday, high noon, it will boil off. There'll be a lot more cloudy blanket that will fool the say the ultrasonic previously. The ultrasonic would read the top of that blanket rather than the top of the actual fluid itself. As you can imagine, would boil off this lower liquid level because that liquid has turned into that vapor blanket and it's got to go somewhere, but it's stuck in that headspace. The conditions of, say, the media itself, the process conditions, when I say it won't affect radar performance, there's agitators in there, there's foam, so there's really foaming levels at startup. If you're doing acetic acid, for example, the radar isn't usually bothered and it will hit through the foam and reflect off the actual liquid level itself. But I would say you would need to position that and use with caution, run a few trial runs and learn where your echoes are, where your signals are, and how they correspond to conditions in the tank. So tricky applications, I mentioned them at the start. Things like you've got marshmallows or lanolin or cotton wool or any of the sort of porous material. These would absorb a lot of the ultrasonic waves or the older radar as well. So they'd absorb them and they wouldn't get back to sender, or the signal would be so weak the transducer and the controller wouldn't be able to make sense of them. It wouldn't really reach the threshold. Again, even on the extreme scale, there's a less so. That's kind of rare, but they do happen. So I wanted to make you guys aware. You've got, say, rock candy and the like in a steel tank, then you've got basically like snooker ball reflections. You know that waves are bouncing, hit the surface and bounce off the surface off the surfaces of the tank, sides of the tank, and go back to that transducer. So there's no difference in the signal strength between what's reflected from the surface of that hard material or the sides of the tank. So it can sort of give it unreliable. It give you unreliably high, unreliably low on a day-to-day basis. It has happened with the old Miltronics, but again, Miltronics is a legacy enterprise in terms of ultrasonic level. It's been around for ages, and you know the technology still holds strong. What it brings is I know it sounds vague, but it's a patented microchip technology. So those signals that were either very weak or sort of not too dissimilar to the signal that was emitted before it was reflected, these can now be processed, especially the weak signals. So previously they couldn't be registered by the transducer, but now they can. They meet a threshold. They can still be converted. This is why the LR100 will work in sort of tricky situations. Again, when I showed you the narrow beams and the progression of radar from 5 to 26 gigahertz, they had issues where you've got oil, which doesn't have a good reflectiveness as it stands by its nature. And when the level of oil will say a few, half a meter or less, going into 10, 20 centimeters in a big tank, it would, in the past, the beam would shoot through and not reflect off the surface of the actual oil, but shoot through and hit the bottom and come back up. So it would just be too powerful, be overkill, and it would hit the bottom, which hits a hard signal because it's a steel tank or whatever, and it can only reflect up. It can't pass through that, but it would pass through the oil before. With the 80 gigahertz, with the shorter wavelength, it's a bit more nuanced. It's a bit more of a surgical incision rather than using a blunt hammer, which was 26 gigahertz. So it reflects off the true level rather, even if it lies close to the bottom where it would receive that hard echo anyway. So this is why 80 gigahertz you'll see not just with Siemens but with competitors. That's why it's been championed as sort of the gold standard now. Now we're talking about footprint. What I mean by footprint is the legacy radar LRs like the LR250 here compared to one of the LR100s on the right hand side. It's got a terminal head. It could be a LR140. You can see how compact it is. This is very compact. This is the horn, the antenna. This is where the signals are shoot out from. And look here, this is quite bulky. The whole thing is quite sort of, look at that. It's on it's a bit clunky to put together and plug and play into your tank right away. So they know Siemens have addressed this because of they can afford to make them smaller now. They can get in and do the job and do it better than say the LR250, and it's much smaller. It's much more compact, much more easy to get in. So commissioning, these are just snapshots from my mobile app. You just connect it in, you enter the Bluetooth pin that you get with your device, and it's of course it's free. But just what used to be carried out on the Somatic PDM, or if you people are familiar with the LU240 on the HMI itself, we could run a 30 seconds to a minute commissioning guide. Now can be done through the beauty of mobile app technology. So it's a very intuitive graphical user interface. You choose your level, for example, material type. So you can have this example for obviously a liquid. You've got your minimum, your high alarm or your high level, and you've got your low level, if that's the bottom of the tank or whatever. You can set as you like. So these are lower calibration points and the upper calibration points. You can. The beauty is, even on the mobile app, if you change the solids, then you'll see another case where it's angled for solids, because solids won't have a direct, not always have a directly overhead or perpendicular radar positioning. For example, here on the right-hand side, we've also got, what is it? Is it just storage, or is it our process? Does that mean there's a flow out and flow in? Do we need to control flow in and flow out, make sure it's not emptying or too quickly or filling too quickly? A plastic tank, so of course we can read through. We don't need to drill into the tank. We can have the radar perched above it, and it will read through the plastic tank. And this, it's really intuitive. And it will get you results, even a volumetric flow. There's a lot you can do here now with the LR100 range. And we're talking about headline benefits for people who are running on sort of remote tank farms. They've got, say, for example, we've got one of the LR110s here, and you've got these several sort of tanks. You can see there's 6 in that picture, for example. What are we talking about when it comes to lifetime savings? So they've got a lower startup current or amperage, and the LR100 compared to, say, a battery of ultrasonics will be lower energy use. So again, everyone's looking for sustainability, and that means savings. So this is where the radar is getting a lot more attractive for those who are running many or multiple storage units. So we're going on to case studies here. So this was wastewater holding. They had, as you can see here, there's an extended nozzle here. This is placed through. This is obviously one of the LR100s. And in the past, they had the ultrasonics, but that condensation from the material in there would build up on the face, and that would mute this sort of signal coming out, it would muffle it. Here, condensation is not a problem, so we don't have to waste time yanking it out, wiping it down, putting it in, running the test again from empty to see, are we getting reliable reading? We don't have to reset anything here. We're not eating away at valuable time for the operator and the commissioning teams. And we've also combined this with an RD200. You set that to multi-output, so you can have level, volume, switch over, and it's visible from at least 7 to 8 meters away. So this is kind of building the package for the end user. Perfect. This is a case where I think it's attracted a lot of attention, and not just from people familiar with PI, is when you've got certain volatile materials or certain dyes and certain chemicals you wouldn't want to open up, kind of harsh or aggressive, then you can read through the IBC itself. It will read through the plastic polymer. You set it up, you can set it up on a mounting flange, and that will read through to whatever level. So you don't have to go around with the dipstick, don't have to compromise, don't have to bring the safety team all on board, and don't have to, it's just wasting their time. And you're passing by with your app, you select through your relevant LRs that are paired up, and you can check the level at a glance. This is the solids. Over here, for example, you could use it here. You could mount this device here. This is an easy Emma flange, because with solids, as you can see here, they don't line up in a neat, even form. Like, it could be acetone, it could be diesel, it could be whatever, but it's all flat and level as liquid. It occupies the shape of the container. Here they don't. They have mounds and angle of repose. So you want to see if you can capture it. And the easy Emma helps you position it in such a way that you're confident of capturing the true level. So the mound and the troughs. What it was is, for this case, the client came to us. So they had a high level switch, but they wouldn't know how quick, again, how fast is that was their pit, or even a vessel or silo here. How fast is it if that's filled with that lime powder or asphalt here as well, or in this case, for both cases, how fast it was emptying or filling. Again, if you can't efficiently monitor your inventory levels, you're not accounting for how fast it's been consumed, then you're not maximizing the available space in that silo. You're going on rules of thumb, and you're probably losing out 10 to 15, 20% of maximum space. The more volume you can fit inside there, the more volume you can disperse later to the trucks and the export. So space is money here. So you always want to maximize available volume. This is for a brick manufacturing. So they had rejects, and a lot of the rejects would be dumped into sand, into an open pit. and they wanted to know, they want to make sure this open pit wouldn't overflow. What we're doing here is we're combining it with this little gizmo here, a fine gadget indeed, called the LT500. It's a level controller. It's LT, it's level transmitter. And you can have an LH100, a submersible transmitter. You can have an ultrasonic transmitter and combine it with the readings from the LR100. So essentially, they wanted to read the level of sand. They want to read through the water and head the sand. So sand reaches a certain point, they know that they're about to overflow. The beauty of the LT500 is that you can take in any 4 to 20 milliamp level transmitter, be it submersible or a DP cell. So that's pressure, using pressure to work out the level, and combine it into the LT500. It's got special screens that are tailor-made for integration with, say, the LR100 range and the LU240, which is the level ultrasonic level non-contact level probe. And I'm taking you through the next slide. We'll take you through the actual features of LT500 and why this controller could really seal the deal in terms of process control. Now with the LT500, which is obviously this controller box here, which is wall mounted, we have either you have single point, you wanted 2 independent applications of 2 separate tanks, or you have an ultrasonic and a radar on the same tank, so you're having redundant. You don't want, if one fails and the other will provide as backup, or just to make to have a sanity check between 2 readings, or as I said, you want to make an average or differential level determination between 2 readings, then the LT500 is your product. It's that controller. So it has ability for a pump in, pump out sort of algorithms. This is a process control. You can attach up to, say, 6 relays for those pumps, put them in there. So it's a lot of these are not just simple in and out, or tank is full, tank is not, tank is empty. It's not just storage. We're looking at pumping out at different times of the day. So you can schedule your pump out to when you know that electricity is cheapest and off-peak demand. This is just getting your process a lot more smarter, a lot more livelier, more proactive rather than passive. So you are making savings, you are making steadfast sort of changes to your process. Even there are certain cases here, as we see at the bottom, there's the alarm relays itself. We can have that read out volume. It will determine the volume, provided you give the shape, the geometry, program it into the LT500. Obviously, this is the LT500 here. That's the LR100. It's feeding in, provides an alarm, and you've got the control. So this could be your control output as well. This could be some sort of weir or notch. Pretend this is sort of flowing out, and this will give you, those level of degrees of control. Where previously, you might have to do a lot of pottering around on a PLC, and this just makes it a lot more, even with the PLC in tow, which is always going to be there, or your SCADA system, this will make it a lot more pain-free and easier on the commissioning engineer. They don't have to, it's just going to be a lot more intuitive to get through the menus. Even for, say, if you have a motor that starts a pump, or you have sort of offset points, these are like, do I wait 10 seconds to start the motor? Do I, or delay it further, or start the motor before? These are offset points. You can establish them. And it will, some of the warnings or diagnostic functions on there will tell you, hey, watch this because this tank is emptying too quickly. This is process visibility. This is what Siemens is delivering. This is what we want to present this as a package. The LT500 will do what the Hydro Ranger or Multi Ranger originally did. Even the LUT series, the 400 series, that you would probably have to overspecify or put a lot of overkill configurations on there to get it right. But because this is open channel monitoring, so we're looking at wear and flume and notches that you use in wastewater. So this will encompass that. Again, normally open channel monitoring is complex, but this will be able to handle it and give you the right control tools needed. So moving on to more on remote terminals and how we want to make sense of our measurement. What do we want to do with that data, and are we drowning in data? So like you saw the RD200, this is also, if you wanted a local readout, you have an RD150, that's great. RTU 3030 series, like here, that's an antenna here to send out, but it stands for remote terminal unit. And to see how it works, in a really basic crude format, here's your LR100, you can see that here. That's reading the level there, but that's reporting, that's been wired up to this, which is solar powered or battery powered. So you can have this at far outside, a mile away, 2 miles away from your control center, and you can have that forms whatever it exports. So it's taking the readings or trend lines over a certain time period from the LR100, and that's sending out an email or emailing as CSV, so you can have it export for your Excel file or an SMS alert, and that goes into sort of a cloud. You see these ones and zeros, it's just like a little dreamy perspective of what cloud looks like. So, you know, there are programming functions on the RTU. So you want to record over a certain interval, you want to record for 5 hours every 2 weeks, then, you know, you can do that and it will report back. And in this case, it will throttle back on the use of the LR100 as well. So it will coincide, it will only take readings from the LR100 at those times. You could have even the LR100 loop powered through this. So it will only activate when that it wakes itself up, the RTU through it wakes itself up and say, I need to record this, you know, and it switches itself off when it's programmed. So there is programming on board. It is intuitive. It's not really like reading hieroglyphics to get that sort of programmed. So obviously the mobile IQ is obviously the app itself. That was the app when I showed you the commissioning. The Serve IQ and Store IQ. Serve IQ is to keep the log data on the site, but Store IQ, you can allow users across, say from California to Germany to India, wherever they are, head office, to access that bulk level data if they so desired. So you can use a cloud gateway. That's another device, but you can use that to accomplish this. So the RTU comes into its own when you are off-site and for example, you only want warnings when the level reaches below 30%. So this will start, it will export those warnings every 5, 10, 15 minutes every hour for as long as that level remains below 30%. So it will, every hour, say for 30%, will keep saying warning, level is below threshold. But when it reaches above that threshold, those warnings will stop. So you're not drowning in data. Now, this is more sort of sales oriented, but I just wanted you to know that in industry, a lot of the site and engineering standards will say we need a contact and non-contact. These are independent. Of course, they run on different technologies. They're activated differently. So this is more, the contact is a bit of a, oh no, switch, that to a last line of defense. But that doesn't obviously tell you real time what the level is. It only tells you when the level is reached too high or too low. LR100 series here would always give you that real time overview and say, yeah, this, you know, real time measurement. So you're always aware in your SCADA what sort of the rate or what's going on in the process. The best engineered solutions are for have these switches along with the LR100 to provide both of them in a quoted package for sort of overfill, low level and dry run protection for the pumps. And just to reiterate, you see here typically that you think, oh crap, this is hitting the it's interacting with that metal element there. It's going to give me a false reading. No, because you use the Echo Profiler on the LR100, you can run that through your phone, through the mobile app, and that will ignore that and go for the true level instead. You'll be able to tune it out. So what are we talking about in terms of the headline benefits? Like you're asking, okay, that's great, but really, we need to know, does it cost us time, money? What are the real savings? Why should we move on from our contact switches that we've had in the past? Why should we go radar? With the level radar specifically, obviously, I spent time talking to you through the drop-down menu commissioning. It's very plug and play, very intuitive. Anyone can get into it, even if you're not well versed in level or instrumentation technology. It is real-time commissioning guidance, and you're only doing it through a phone. You don't have to sit through a terminal and try and configure or parameterize through that way. And you can have multiple on, say, one mobile. So if you are walking through a tank farm area or an area of 3 or 4 tanks, you can see at a glance the confidence on the radar signal and also the real-time level as you're walking through or as you're situated there in that location. So it makes it handy there. You're no longer having to run to a terminal and then you're wasting time and what have you, when you run and check that reading will be different because you've had to take time just to go and access that reading. So it's kind of lagging behind. In terms of maximizing space availability, how do we make inventory planning say for solids bins or asphalt, anything tricky, easier. You know, things like asphalt, it will get a lot of gloops over in there, so you want to try and use as much as possible. Then some of that vessel might be unavailable because it's already encrusted with a lot of the muck and viscous material. So we want to maximize the silo capacity. Again, for liquids, you want to protect your pumps. You want to stop them dry running. You want to stop cavitation. So this will deliver on that front for safeguarding, maximizing your available space volume, and safeguarding your pumps and key downstream or upstream assets. So time saved, yeah, you can get that without narrow beam focus. Is a higher chance of getting it right the first time and not having to clamber up there and fiddle with the HMI on top of a large platform or silo and eat into a lot of safety, HSC time and the like. You get immediate diagnostic data and real-time data through your device as well. Diagnostics on the LR100 and the LT500 itself. If you are talking a controller package, a governing controller package is a lot more sensible, means a lot more to your operations and instrumentation engineer. And obviously for you've got a cluster of these devices, you have better lifetime savings. So if we're moving on to when to use it and when not to use it, then here's a verdict. Within 2 millimeters, you'll get a really top performance from the level radar, regardless of what the medium itself, what it is, the process media and the process conditions. Yeah, ultrasonics, it could be flummoxed by the vapor blanket and read off that instead of the actual level of your solvent or acid. If you've got a really aggressive application, then you have that extended flange that we saw there, the extended nozzle to kind of protect it. You can stick that through an easy aim or a mounting bracket, and because it's narrow, it can still read through to where you need it to be. So I think with ultrasonics, they've come to the fore. They will always be the standard, I believe, in wastewater because of the governing controllers that they've used in the past, the LUTs, the hydrorangers, and multi-rangers. And you can get a few blind transducers in there and then feed them into a controller. Ultrasonic will always be there, and I wouldn't say LR100 is the killer app, and it's not going to sort of usurp the ultrasonic from its prime position. But again, it's when you use radar for challenging process media, or challenging process conditions. With solids, you've got to be wary, and we use showing you the examples where they weren't always adjacent or perpendicular to the level. They are angled using the easy aimer to angle it so you get the best view. Because they pile up uneasily, do you want to see where it lies? You don't want to see the top, the bird's eye view of the peak. That won't tell you anything. You want to get angle view to see the true sort of height. Then you can make a differential sort of calculation on, yeah, this is kind of the average height in that silo of grain, sand, granules, what have you. When it gets to sort of aggregates or really aggressive applications, then some of the older radars are probably, they're built for this. So because it's PVDF or polymer-based covering housing on the LR100, you might need a rugged one, which is stainless steel housing for the older radars. So again, this is where we come in. You talk to us, we talk to you about the application. We'll suggest the best one that's most resilient for it. When we say these heavy applications, you're thinking sort of cement production, certain plastics or polymers with a lot of shakers and vibration, coal fly ash. A lot of that conjures up dust as well, which is why certain ultrasonics probably couldn't work, because they couldn't penetrate that dust, that it would dampen that signal from the ultrasonics, and that signal wouldn't get back to the receiver. The radar, you won't get that issue. So we wanted to really ask people, what technology have you been relying upon? What's been the site standard, and what are you thinking of? Was it contact? Do you want to move on to continuous or real-time level monitoring, which is obviously what radar is? Is radar being mandated as a prime choice, or can we help you decide what's best? That inventory planning for solids and liquids alike. Are you getting sort of pressure from above in terms of, are we, do we need to maximize space on there? Do we have a blind spot? Are we using rules of thumb to dump this into the truck rather than waiting and managing the space in there and the product that we sent out? And essentially, what are we looking for in communications and diagnostics? Do you need the control of the LT500, or are you content with using HARP, or do you want to move it to Profinet for sort of faster network traffic and easy integration with your SCADA? That caps off the LR100. Thanks a lot. I know that was a lot to get through, and from here on now, I am going to take you through the new Siemens solution for conditioning monitoring, the SCM IQ package. So this is a novel tool. It previously we had condition monitors that were run but didn't have the smart communications output. So what we've got here, and I'll show you. You'll see these acronyms, and I'll show you what they look like. And the next slide is multi-sensor, the MS200. The smart condition monitoring package itself comprises the MS200 and the the Cloud Connect Gateway, the CC220, and it's all run. It's all under the umbrella of this SCM IQ app. I'll take you through the range of applications. We'll take you through security as well, because we are talking cloud and accessibility through the cloud. How to onboard it, and sort of installation examples, and what it looks like on your screen on your tablet. And we've got a Sussex, the brick case that we did back in March. And as a process, as a factory manager, as operations manager, what do you stand to gain? So just taking you through the MS200 itself. So this is it looks like a dongle, and it's threaded onto your asset, would be a pump or a conveyor belt housing or a gearbox, or certain turbines, the housing itself. It will tell you the temperature, and it will tell you vibration in 3 axes. It runs it reports back 1 per 100 seconds. So that's one transmission or burst transmission per 100 seconds, and that will give it a long battery life as well. So there are certain applications where you won't use it. If it's a cyclic every second, it won't tell you. It won't tell you anything sensible anyway. So we're looking at sustained vibration or displacements in a belt or a housing over time. That's the MS package. That's the transducer itself. Yep, and this is the gateway. This connects it. So we're going for Bluetooth, and this will report back to the Cloud Connect Gateway. This needs a hard power service line like that running on AA batteries. The transducer, this will need a hardwired power, and it will need an internet gateway, an Ethernet, something to connect it so it can get up to the cloud. You can put this in a cabinet somewhere. The back to the MS200. Sorry, I forgot to mention that it's very rugged. It's IP68, so cold, high vibration, a lot of noisy, really mucky, challenging environments it will cope with. Obviously, Cloud Connect Gateway, you need to put that away safely. That's going to connect it up to this MindSphere at the bottom of the screen here, if we can see that. Again, what does this SCM IQ app entail? It's very smart. It's kind of a cliche, but it's using machine learning to learn the ins and outs of your operating envelope. Is this vibration, is it normal or abnormal? Are we remote? Are we working within the bounds of operating envelope, or are we out of bounds? So I'll show you a screenshot from the app as well. But again, we can configure it like with the RTU, the remote terminal unit that I presented in LR. So email notification for certain groups, certain key members of your maintenance and operations group. And that's the IQ. That's just day-to-day trending. Within 2 weeks or appreciable time, it will develop that anomaly side. So it will tell you, this is anomalous. But that obviously it teaches itself, so you can fire and forget, within reason, and try and make sense of, oh, hang on, I'm detecting anomalies here. It's been running over certain days. This is something that the operations maintenance got to address before it gets out of hand and it kills the pump, or we have a major breakdown. We don't have a spare for that. So yeah, so what we do, what Siemens are trying to do here is everything: process quality, yield, logistics. And I think the SCM package could help you smooth out and touches all aspects of your operational life. We're looking at preventing big key assets failing before, prematurely. Can we get yield? Can we dial down operating of that pump, or get it within, lower it down the RPM, so we can get better lifetime and better even yield, even reducing like utilities as well. Steam usage and the like. When we look at being sustainable, it's not just good for the environment. Obviously, at the bottom line, it means better savings, lifetime savings. So this is where the SCM IQ sort of fits in into where Siemens is going. Yeah, so we're talking about, okay, where can I put this dongle, this MS200 rather, multi-sensor 200? You can put it on pump casings here. You can have a lot of these when you see these things, you won't just see, oh, it's just in an oil refinery or in a chemicals facility. You will see these everywhere. So if you're in process instrumentation or you're a novice, it doesn't matter. You'll be able to apply this and pretty much any industry you see it come across, even up in certain pressure relief valve systems, depending on how hard they chatter, or how much process noise you're expecting, even heat exchangers. So we're talking the scope here is either pumps or systems assets themselves, and even process control. We're talking everywhere, and this is where we could export it to anywhere. Again, this is just reiterating, it sends, that's powered by battery, it sends it through Bluetooth, through the Cloud Connect gateway, and that's into the MindSphere itself, the cloud access where you pick it up through your mobile device, your web GUI. Yeah, and this is just, we're talking security. We've had a lot, certain applications are maritime or in the defense industry sector. So I understand that security is crucial. Nothing will fly off the ground, nothing can be sanctioned without security. So we've got security at the Bluetooth level, just it's sort of pin secured access here is encrypted, that burst is encrypted to the cloud gateway. The SCM IQ app, it's going to have secure two-factor authentication as well, and you can assign control or unassign control, using that multi-factor part. Now, I would defer, if we're talking security, I can defer to members of security, the technical support team at Underwoods, namely people like Paul Corley and Graham Corley as well, when it comes to cybersecurity. And I know it's going to be foremost in your mind, so this is where we understand. We want to try and reach sort of really trying to understand before we offer you a package and allay your any concerns on it. So what we're talking about onboarding, how do we set it up? There are, as mentioned, there are several security layers from plant asset to the MindSphere level itself. When you power up the CC220, that will be hard powered up through remains. You can assign your MAC gateway settings, so you assign this is the MAC address for this MS200 on this MS200. The second device, third device, you have individual addressing ports. You could use a network switch as well to sort of manage that traffic from the cloud gateway to the MindSphere. So what does it look like when we're looking at the trending? We're looking at, for example, this is the temperature at the top. That orange line, you see temperature is kind of dropping. It's stable, it's plateau. We see a vibrational, the X, Y, and Z planes, and there's anomaly status that will kick in when it's learned. It obviously cannot kick in the first 5 minutes. It needs to learn the daily rhythms of your machine, your rhythms of your operation, that specific asset. And we can run tests as seen on the right hand side over certain time frames, and you can choose your data points. I just want to measure temperature. I want to know temperature over the last 7 days, or I just want to know X, Y, Z, the acceleration in G-force across those planes. So we can drag and drop and select kind of slices of what we want to analyze. And then you need to report back to your boss, say, yeah, it's been playing up for the last 7 days, boss, or over the last 21 days, we haven't seen anything untoward. So this is what it looks like on say, it's best to work on the tablet. You can access through your mobile phone, but I would probably recommend your tablet so you're not hiding any icons or radio buttons. So we're looking to the endpoints of where we sort of use it. It's kind of, you can clamp it in, you can have a glue-on base for temporary mounting, or it's screw-in. This is probably the best thing. It's either an M8 or I believe an M8 screw-in bolt. This will keep it secure. You can plug and play this, so you have 5 of these sensors connected to one gateway. So if you were, say, 10 MS200s, you'd need 2 Cloud Connect gateways. But you can just unscrew it and place it somewhere else. Just be warned that you need to give it time to relearn the new vibrational or displacement for that side. If it's a different side of the pump, underside, overside, or a different part of the plant, you can drag and drop, and it won't ask you to reboot anything at the SCM, the IQ end, the app itself. It's kind of plug and play. This is a pilot case study that I was really honored to be with. I was with Andy Killick and with Harry Catchpole of the Siemens product manager for the SCM range. Again, the client was well aware, and right before the very eyes, they just dropped it. They dropped it here on a control box, but that was just for just to try that out.
and within minutes they could see feedback. Again, what it was is that the client can see when downtime is due, or when it's kind of rocking off its hinges. It could be a pump or a gearbox housing. They know it's things that normally it's like, oh, I can hear a bad noise. This is a bad knocking noise, but now there's something quantifiable. There's that data to give you that forewarning. So we're talking less concealed failures, and so we're not looking at 3 o'clock in the morning. We need this belt's down, our whole production line is down. Need that part like yesterday. Again, with lines for access to who you want or you don't want access to, you can reassign for security who has access to that data. Again, they just like the being able to. One of the guys on site was reading it. You know, he was at home and he said, "Oh, I can see that in MS200, which was on that box there, on that gearbox there. Yeah, I can see it. It's happy or it's unhappy." And it was just kind of like playing like a little mobile game for them. So it's really intuitive. According to this guy, got quite addictive. So what does it look like? When we've got the MS200 out there, like that could be out on any site you have, screwed in or glued in. And we've got the CC20, the cloud gateway here. And above that, you can see a Scalance network switch as well. We've just got it hardwired here. And again, that's exporting into the cloud, and through the cloud you've got your login details and email on login onto SCM IQ, and you've just got, like you said, the graph for trend outputs, and you can set trends and assign instruments and go through a lot of onboarding. That's all available out there on YouTube on the commissioning side of things. So again, just remember the SCM IQ package entails the MS200, that's the multi-center itself, Cloud Connect gateway, and the network switch, which is that. Those are the 3 components. So you can have an aerial. You can even have an aerial in place of the network switch, just to make sure you're getting that 4G signal. Just have a SIM card in the CC220. So just in case you don't want a network switch, they're hard to come by, that's fine. Just have a suitable SIM card to give you that 4G access. We're talking opportunities. I'm talking more Salesforce guys out there, gearboxes, pumps and drives, paper, aggregates, and FMCG. So we're covering the breadth and depth of industry in the UK. And just to kind of finish off here, what are we looking at in terms of key observations? Again, the anomaly app that kicks in after a while, a week or two, whatever's the normal rhythms are, it will determine when it's out of sync, when it's not, and again, when it's abnormal, normal versus abnormal. The batteries themselves, again, they last about 2 years. These are batteries you plug into your remote control sort of thing. So it's not, we're not powered up. It's not going to be bothersome for anyone to set up there. Not be a real pain to do. So scalable. So you've got a large at this plant setting, a large pump, a large heat exchange network. You can have 3 gateways, 15 of these devices, or you've just got a couple of places to check out. Then fine, you can have 2. But if, as your process grows, or as approval for using this SCM package grows, you can add them. You can add the number of MS200s. That's not the expensive part of this whole package. You've got immediate feedback within 5 to 10 minutes of logging in. Just give the line starts. The temperature and the XYZ, the 3 lines to give you the feedback on displacement on those axes. And there are plans in the pipeline to run sort of, which we're talking edge, so people can view it on a local terminal or a PC in the plant rather than being cloud-based. Again, don't quote me on that, but that could be within a year or 2.